This is Chapter 1, Module 4, Homeostasis. The learning objectives of this module are 1. Define and provide examples of homeostasis, and 2. Define and provide examples of negative and positive feedback systems. Homeostasis refers to the existence of a stable internal environment. Homeostasis is the foundation of physiology. The regulation of homeostasis is the adjustments the body must make to maintain this stable internal environment. Two general mechanisms are involved in the regulation of homeostasis. Number 1, autoregulation or intrinsic regulation occurs when a tissue or organ automatically adjusts in response to a change. For example, when oxygen levels decline in a tissue, the cells release chemicals that dilate or widen the blood vessels. This dilation increases the amount of blood that can travel to the area, thus bringing more oxygen with it. Number 2, extrinsic regulation. Either the nervous system or the endocrine system will adjust the activities of several organ systems simultaneously. For example, when you exercise, the nervous system will cause your heart to beat faster and your lungs to breathe faster, but will also cause your stomach and intestines to decrease their activity at the same time. This ensures that the necessary amount of blood carrying oxygen will be delivered to the active muscles where it is needed. There are some major differences between the nervous system and the endocrine system. The nervous system directs very rapid short-term responses like pulling away from touching a hot stove. This response is very localized and only affects the area touching the hot stove. The endocrine system, in contrast, releases hormones that affect tissues and organs throughout the entire body. These responses may not immediately be observed, such as the regulation of blood volume in the body. Regardless of which system is involved, homeostatic regulation keeps the internal environment within certain limits. Regulation of homeostasis requires 3 parts. First, a receptor, which is a sensor that is sensitive to change. Second, a control center that receives the information about the change and sends out commands to the body to adjust to the change. And third, an effector, which is a cell or organ that responds to the control center. The effector will either oppose the original change or enhance the original change. An everyday example to illustrate these parts is the maintenance of a comfortable room temperature. On a hot day when the temperature inside a room might begin to rise above the set range, a thermometer, which is the receptor, senses the increasing temperature. The thermometer alerts the thermostat, which is the control center, that will then trigger a response from an effector, the air conditioner. When the temperature rises above the set range, the thermostat turns on the air conditioner and the temperature returns to normal. This type of response is called a negative feedback response, in which the response is exactly opposite that of the original change or stimulus. When the temperature began to rise, the response was to lower the temperature. An important example of negative feedback in the body is the control of body temperature. Events in the regulation of body temperature occur when the body temperature rises above normal, which is 37 degrees Celsius. Receptors in the skin detect this change. The receptors alert a control center in the brain called the hypothalamus. The hypothalamus will cause increased blood flow to the skin surface. This will increase sweating and lower the body temperature. Most of the homeostatic regulation in the body is performed through negative feedback. Only occasionally will positive feedback be used. Positive feedback is when the response of the body is to exaggerate or enhance the original change instead of opposing it. Positive feedback is rarely used in daily life. For example, positive feedback would never be used to regulate body temperature. If the body temperature were to rise and positive feedback were used, the response to the increased body temperature would be to increase the body temperature even more. This would cause great harm to the body. Instead, positive feedback is used in a potentially dangerous or stressful process that must be completed quickly before homeostasis can be restored. For example, an immediate danger from a severe cut can cause a substantial loss of blood. This will lower blood pressure and reduce the efficiency of the heart. When the blood vessel is damaged, cells within the vessel wall will release chemicals that begin the process of blood clotting. These chemicals start a chain reaction, causing a blood clot to form. As the clotting continues, each step of the clotting process causes more chemicals to be released, accelerating the process. This process continues to escalate until a blood clot is formed that is big enough to stop the bleeding. This is an example of positive feedback because the response of the body is to exaggerate and enhance the original response of releasing chemicals to continue the blood clotting. Another example of positive feedback in the body is the process of childbirth. In labor, hormones are released that cause uterine contractions and cause the cervix, or the opening of the uterus, to dilate. These hormones cause the release of more hormones, which cause larger contractions and further dilation. This process continues until the cervix is dilated to 10 centimeters and the uterine contractions are strong enough to deliver the baby. Without this positive feedback, the mom would be in labor for an undetermined amount of time with no successful outcome. A state of equilibrium exists when opposite processes or forces are in balance. For example, in the example of body temperature, a state of equilibrium exists when the rate of heat loss equals the rate of heat production. Each system of the body functions to maintain a state of equilibrium to keep vital conditions within normal limits. This is called a state of dynamic equilibrium because these systems are continually adapting to changing conditions. Throughout this course, we will introduce each organ system independent of each other. However, in reality, each organ system interacts and is dependent on the other systems.